Welcome to the workshop video on statistics and probability. This is content assessment for 7th grade math within the Summit platform. Even if you don't use the Summit platform, though, you can make use of this video if you're a 7th grade student that needs to learn these skills. What I'm going to be doing in this video is mostly practice. I'm not going to do a lot of explicit teaching of the skills. I did that in a separate video series. And so if you are looking for that, make sure you watch those videos instead. I will link in the description of the video to that. But if you are ready for the test and just need a little bit of review or just need a little bit of a final push before you try again, this could be the video for you. Make sure that you use the practice by pausing the video before I review the answers so you have a chance to practice with me as you go along. And if you find yourself not knowing how to do it, I suggest, again, that you go back and watch the other videos. So the first objective is to understand how probability works and how to figure out the chances of events, and that all of these are going to be between 0 and 1, and that express the likelihood of the events, with 0 being impossible and 1 being certain. So, and then 0.5 meaning just as likely to happen as not happening. Below that, you have unlikely, and above that, you have likely events. All right, so let's start with the first practice problem here. The probability of an event is 0.75. So first of all, would you consider that impossible, unlikely, just even, very likely, right? Or actually certain? So of course, that's going to be a likely event because it's a high probability, closer to 1. So what number could be used for probability that's even less likely to happen than that? Well, it would be anything that's below 0.75. So 0.5 could work, 0.3 could work, anything like that. Okay? So that's the first one. Again, this is a likely event, but a less likely event would be something like 0.5 or 0.3 or even 0.74999999. Anything smaller than 0.75 would work. Following in the same logic, the probability of an event is 0.04. Then there's another event that's 0.5. Which one is more likely? So that first event is less likely than the second event because it has a smaller value, right? So this is going to be less likely. So again, you judge the probability of the event and the likelihood of it happening by looking at the number. The closer it is to 1, the more likely. So on these two, again, this is 0.33, this is 0.31. Which one is bigger? That one is. So the first event is more likely than the second event is. The probability of an event of 0.5, and the other one is half. Remember, there's different ways to represent probability. You can do it with decimals, with percentages, or with fractions. And in this case, half and 0.5 are the same thing. So this will be just as likely or equal chance of happening as the two events because they are the same probability. Probability of an event is 0.57. That is less likely than an event of a probability of. So we're looking for an event that is more likely than this event. So any number above 0.57 would work. 0.571 would work. But 0.59 would work. 0.7 would work. Anything that is above 0.57, even 1, all right, which would be certain. All right, so a lot of questions in the test are actually like that. You just have to look at the answer choices and pick the ones which are more likely or less likely than the one given in the prompt. So fairly straightforward when it comes to this objective. What is the probability of getting heads on a coin using fraction, percentages, and decimals? The reason I have this question here is because you do need to practice how to convert between those if you don't know how, because the problems will assume that you know how to do that. And so I'm going to include that on the playlist that this is a part of, because I think it's important to remember to do that if you are trying to pass this assessment. It's a rational number skill, but it's important. So the way we do probabilities, remember, is we put the possible outcomes in the bottom and then the number of events that I'm interested in the top. So coin has 2 possible outcomes, heads or tails, and I want heads, which is 1 out of the 2 outcomes. So the fraction is half, which is, of course, the same thing as 0.5 or 0.5, and that is the same thing as 50%. So once you start with the fraction, you just do the top divided by the bottom to get the decimal, and move the decimal twice to the right to get the percentage. And that's how I do it. And since it's always starting with fractions, that's the sequence I go into when I'm trying to figure it out what the probability is. Now, what would be a probability higher than 0.3? Well, anything bigger than 0.3. So 0.5, 0.6. The only thing you cannot do is go over 1 because 1 is the maximum. By the way, you can also never go under 0, right? 0 is the minimum. 0 is no chance. So negative chance doesn't make any sense. And bigger than 1 doesn't make sense because that would be a more than likely, more than certain, which doesn't make any sense. Certain is already certain, right? So what is the probability of an event that is certain to happen? Speaking of which, that is 1. What is the probability of an event that is impossible to happen? That is going to be 0. What is the probability of an event that is unlikely to happen? That's going to be between 0 and 0.5. What is the probability of an event that is likely to happen? That is above 0.5, but less than 1. All right. And then what would be a valid probability for an event that has an even chance to happen or not happen? That would be exactly 0.5. All right. So that's just definitions that you need to know for the test. True or false? Probabilities cannot be negative. It is true. I just said that. You cannot have a negative probability, so it's true. And explain why probability is larger than 1 and impossible. I also already said that. That would be expecting it to be more than certain. And I don't really know. More than certain doesn't make sense. So I'm going to write more than certain and then get a red pen and just be like, that's nonsense. That's basically what I mean there. All right, our second objective that we have to practice with this is going to be to use probability to model the chances of events actually happening in fractions, decimals, or percentages. So we're going to practice these problems in all of those versions, okay? Okay, so let's do the first one. What is the chance of getting a 2 in a 2 6-sided die? Well, the number of events, the way to do this is always this. This is the number of possibilities, and this is the number of events that you actually are interested in. And that's, you just divide them and create a fraction. So there's 6 sides to a dice, and I just want a 2, which is 1 out of the 6. So you don't put a 2 there. You put the number of events that would satisfy what you're looking for. So it'd be 1/6, which would be the same thing as 16.6% or 0.16. Because when you get in the calculator, 1 divided by 6 gives you a 0.16 repeating, which is the same thing as 16.666666%, and so forth. All right, so that's it. The next one is there's 3 red caps, 7 blue caps, and 2 yellow caps in a closet. What is the probability of getting a blue cap if selecting at random? So again, I need a total number of possibilities. So I need to add a total. So 3 plus 7 is 10, plus 2 is 12. But I only want the blue caps, and that's 7 of those. So the chance of that would be 7 out of 12. And again, you can put that in the calculator to try to figure out what that percentage actually is. And that would be the same thing as 0.58 with 3 repeating. And if you move the decimal twice to the right, that is 58.3%. So you start with the fraction, divide the top by the bottom to get the decimal, move the decimal twice to the right to get the percentage. Now, you're not going to be asked to show all 3 in the test, but the thing is that the options, the answer choices could be in any of them. So you do need to know how to convert for any of the 3. 17. 17? 17. If the choice is random, what is the probability of selecting a weekend day out of a week? So how many days are in a week? We have 7 days in a week. And how many weekdays are there? We have 2. So the probability of that would be 2 out of 7. So that would be the same thing as 0.2857, which is also the same thing as 28.57%. So you just get the 2 and divide by the 7 in the calculator and then move the decimals twice to the right to get the percentage, right? Next one. If the chances of landing on a 6-sided die are random, how many are you likely to roll a 6 if you roll 120 times? How many times are you likely to roll a 6 if you roll 120 times? Okay, so like we talked about in the teaching series, to solve problems like this, you got to figure out the probability first and then multiply by the number of times you're doing it to get the number of times you're likely to get that event occur. So let's figure out probability. So we're going to want a chance of landing on a side of a 6 die at random, what is the chance to roll a 6? So we're going to roll a 6 is 1 out of 6, just like the first problem we did, right? Now, we're doing this 120 times, though. So if we're doing this 120 times, you have to multiply and times each other, and then you get your answer, which in this case would just be 20. All right, so if you do this 120 times, you're likely to get at least 6 times, where 6 rolls by, since 1 in 6 times is going to be 6s, according to the chances. All right, let's try to do 19. A deck of cards has 13 hearts, 13 diamonds, 13 blacks, and 13 spades, right? So the hearts and diamonds are red, and the clubs and spades are black. What are the chances of drawing a red card? All right, so you don't really need to worry about the types too much. Is just figuring out what the total is. So the chance of red card, total possible outcomes is 52 cards if you add them all up. And in red cards are going to be 26 of those, which is actually half the deck. So honestly, you didn't even need to do the maths because you should have known half the deck is red, right? So if they're all 13 and half are red and half are black, so the chance of this is going to be half, which is, of course, the same thing as 0.5 or 50%. Now, we're not done yet. There's a second question. How many red cards would you draw if you drew 20? So remember, the way to do that is once you have the probability, you multiply the number of times you're doing things, and you figure it out. So half of 20 is 10. So you're likely to draw 10 red cards if you draw 20 cards out of a deck. Now, is that actually going to happen? No, that's just what's probable or likely to happen, right? That's what this means. What is the probability of choosing a weekday at random not ending in Y? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. They all end in Y. So what is the chance of that happening? 0. It's not possible. If there are no possible or outcomes that satisfy you out of the set of possibilities, the chance is 0. So that's an impossible event. Isabel Music's playlist has 12 rock songs, 15 pop songs, 13 hip-hop songs, and 10 oldies. If she puts it to shuffle at random, what is the probability that a pop song will play? Same as we usually do. Grab the total out of this. So this is 13 plus 12, which makes 25. 10 and 15 also makes 25. So we have 50 songs here to choose from. And out of those 50 songs, 15 are pop songs. So 15 out of 50 is what you're looking for, which if you convert that to other numbers, you're going to have 5/8, which is the same thing as 5 divided by 8, or 0.625, or 62.25 if you move the decimal twice to the right. And I got the 0.625 by getting 5 divided by 8. So I'm reminding you how to do the conversion. So you don't even need to watch the other video. All right. So now the tables. Sometimes they're going to give you a table. It's the same thing as giving you a list. Okay. They want to know here, what is the likelihood of winning Brontosaurus on the next spin? So remember, you can use the probabilities of previous events as to figure out the probabilities of future events. So if we want to try to get a Brontosaurus, well, that is 60 out of the total that I had, which is 160. And then you can simplify and figure out the percentage and decimals as well, but that's basically what you do. Total possibility and the ones you want. So again, this would be 60 out of 160, which is the same thing as 3/8, or 0.375, which 2 decimals to the right is 37.5. To get the 0.375, you just get the calculator and do 3 divided by 8. All right, so that's that one. All right, let's do 23. So lots of practice here. We're going to try to get you good at this. So there's 24 students, and he's assigning a group project. Africa gets 6, Asia gets 8, Australia gets 4, and Europe gets 6. Now he's going to do the same thing to another class, and he was going to ask a question. What is the probability that Miss Woolsey's class will not be assigned a project on Europe? All right, so if you're a student in his class, what is the chance of you not getting Europe is what they're asking you. Well, the total is in the bottom again, so we got 24 total in the bottom. And then we have European student, the ones not choosing Europe. So Europe is 6 out of those, so that means the rest, 18 of them, is going to be the chance of getting Europe. You can also figure out a chance of Europe, and then when you get the answer, subtract that from 1, but the answer would be the same, right? So 18 out of 24 is how you would do this. So the answer here is 3/4, because 18/24 is 3/4, which if you get 3 divided by 4, you get 0.75. Move the decimal twice to the right, that's 75%. That's the chance of not getting Europe. If you had figured out the chance of getting Europe, you would have gotten 25%. And so the difference between that and 100 would be the chance of not getting Europe. The chance of the event not happening is the converse of the chance of the event happening, which is 100 minus the percentage you got, or if you're doing with fractions or decimals, is 1 minus the fraction or decimal that you got. But you can also pick the events to satisfy you and then go straight to the answer. And that's what I did when I did 18 times divided by 24. Now, if you assigned this project to 32 students in a different class, how many students will be assigned to Asia? All right, so what you have to do to figure that out is first figure out probability of getting Asia, and then multiplying that times the number of events. All right, so we're going to have to do that. Let's see what we get when we do it. So the probability of picking Asia is 8 out of 24, which is the same thing as 1/4, right? Yeah, I had to stop to think about that for a second. It's not 1/4. When you simplify it, it's 1/3. So I fixed it. So then once you have the probability as 1/3, you multiply that times 32, and you get about 10.67 students, or about 10 students. Why did I round down? Because if you have 10 students and then 2/3 of a student, you don't really have another student. So about 10 students will be assigned to that, close to 11 potentially, but most likely 10 students, because you won't quite make the 11th one. All right, so that's 23. And we have one last problem here to put in this video, which is Josh is trying to win a game, and he has to land on an odd number. So what is the chance he will lose? Now, as you can see here, there are 8 numbers total, and half of them are odd, and half of them are even, or no. No, you got to look carefully. There's another 2 over here. So that's lesson learned, right? Look at the thing carefully before you do it. So let's see. He needs to land on an odd number to win. So landing on an even number is what makes him lose. So let's count. We have 1, 2, 3, 4, 5 even numbers out of the whole. So that would mean 5/8 is the chance of him losing this game, which does give you 0.625 or 62.5% when you actually convert to decimals or percentages. Now, there are a few extra problems down here in the bottom, which have to do with the kind of content that you would need to get good at to pass the additional focus area. And they're honestly just compound situations. And you are free to skip the rest of this video if you're not interested in watching that, because I'm going to do the objective 3, which is a completely different kind of thing. It has to do with descriptive statistics on the next video. So it's up to you if you want to watch the rest of this or not. This is more meant for people who are trying to pass the extra. So when you have a compound event, the way to figure this out is you can list all the outcomes to figure out the bottom of your denominator, and then look at how many in the list satisfy what you want and put that on the top of the denominator. Okay. So the first problem here is that it's not really a compound problem, though, because it's more of like similar situation to what we did before, but it's also a lot in the extra PFA, so on the additional. So anyways, there are a survey of 80 students, and 24 of them said that they liked math as their favorite subject. So if you try the same thing with 300 students, how many of them are likely to pick math? So you use the past, right, to figure out your probability, and then apply that to the number of variations you have by multiplying to get your results. So let's see how that looks like in practice. So you got to get 24 out of 80 because that is 24 kids that like math out of the 80 to get a probability that is equivalent to 3/10 and or 30% or 0.3. Now, when you multiply that times 300, that will tell you that 90 students in the school are likely to pick students as a favorite math. All right. Now, how many possible outcomes are there for rolling a 4-sided die and a 6-sided die? Right? So you can do a list, you can do a tree. I'm going to do a tree here to show you what it looks like. I can get a 1 on the first die, right? And then I could have 6 different numbers on the other die. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, that is also going to repeat for number 2. It will look exactly the same with 6 partitions. And for number 3. And for number 4. So if I roll a 1 on the first die, I could 1 through 6 on the second die. If I roll a 2 on the second die, I could do 1 through 6 on the second die. And then so forth for the other die. So that if you think about it, the chances are 4 times 6. So that's going to be 24. So 4 times 6 gives you 24 possible outcomes for this situation. Remember, the way to figure out possible outcomes is just multiplying the number of outcomes of each situation by each other. Or you can make a list and count, which is either way works. Now, what is the probability of getting heads on a coin flip and then rolling a 3 when rolling a 6-sided die? Again, we can do this by listing. So let's try to do that. And there's a shortcut at the end too. I'm going to do that also. So if you have a heads on the die, and then you have the on the coin, sorry, and then you have the die where you can get 1, 2, 3, 4, 5, and 6. I'm looking for, and then there's tails with 1 through 6. But I am looking for the situation where I get heads and a 3. So that's just this one. Heads with a 3. Out of 12 possible outcomes, because this could be 1 through 6 also, right? So I already know it's going to be 1 out of 12. So by doing a little diagram, and by the way, a lot of the question test will have the diagram made for you. So I have to look and count the number of possibilities, and then look at the number of possibilities that actually satisfy what you're looking for. Some questions will ask you to identify a diagram that does seem correct, though. So you do need to know how to make these diagrams, and that's why I showed you the tree diagrams a couple times. You can also have listed, right? You can have listed saying like heads with 1, heads with 2, and so forth, and then tails with 1, tails with 2, and then so forth. And you would have listed all 12 outcomes. That works as well. Now, there's a shortcut. You could have figured out the chance of the first event and multiply it by the chance of the second event. The chance of the first event is half, because there's 2 possible outcomes when flipping a coin, and I only won 1 of them. The chance of the second event is 1/6, because there's 6 sides to a die, and I only want the side that says 3. If you multiply those fractions, top times top and bottom times bottom, you get back to the 1/12. So that's a lot quicker than having to list things, right? So so the other shortcut is figuring out the chance of the first event and the chance of the second event, and then just multiplying them to get the chance of both events happening together. This works as long as the events are independent from each other, and the chances of one don't affect the chances of the other. And that's all you're going to see in 7th grade probability, even on the additional. Now, last one, probability of getting heads in a row when flipping coins 2 times in a row when flipping the coins 3 times. So I'm going to list this because it's hard in my head to figure out all the possible outcomes to try to do it with the math shortcut. So that's one of the options that I can get, or I can get heads with tails. So since I did trees for the other one, I'm going to do a list for this one. Or I can get heads with tails with heads, or I can get heads with tails with tails. And then I can have all of these again, except starting with heads. So tails, heads, head, tails, had tails. I could also have tails, tails, head, and tail, tail, tails. Okay. Now I want to see 2 tails in two heads in a row. So this certainly qualifies because it has 3 in a row. This qualifies. This does not. This does not. Oh, this one qualifies. And it looks like only those do, because then the rest of these are just tails. So it looks like to getting 2 heads in a row is 3 out of the possible 8 chances that I can have, which is the same as 0.375, or if you do 3 divided by 8, and then move the decimal twice to the right, is 37.5% the chance of that. So there you have it. That's probability, including some extra stuff that might be helpful to help you pass the additional. I hope you found this helpful, and I'll see you in the next video when I'm doing objective 3, which is all about descriptive statistics. I'll see you guys then.